Greetings and welcome to my new calculus channel. So, I'd like to talk about how mainstream cranks get such high numbers of subscribers and basically have the lowest quality videos on the web. For example, this black pen, red pen has up to 100K subscribers on one of his channels. Another one here, Professor Dave explains, almost 3 million subscribers. The guy's an idiot, doesn't understand calculus, doesn't have good videos, but he has a very high number of subscribers. And guess what? On that, it's very easy for him to earn between, who knows, $15,000 to $30,000, depending on the amount of traffic. And obviously, there's a lot of traffic. So I'm not going to waste time with Dave because I've already addressed this idiot. I'm going to address a different idiot today. This little Chinese guy, whoever he is, calls himself his channel Black Pen, Red Pen. So let's address a very recent video 9 days ago called "I Had an Adult Scream at Me Because He Insisted 0.999 equals to 1." Because he insisted, I guess, not the adult. So the argument here goes that somebody is telling him, well, these two things are not equal. So let's just move along in the video.
Confidently incorrect. Nearly
And
1 is 1.
I'm going to be skipping the garbage because I just want to get straight to his points. So
1. How about if I tell you 2 times 1/2? Is this also equal to 1?
Okay, let's just go back here a bit. Let's
One.
just go back here, let's say.
Well, if you want to say 1 is the only thing that's equal to 1, how about if I tell you 2 times 1/2? Is this also equal to 1? Yes, right?
All right, so this guy is setting up a straw man argument here. He's misinterpreting what his opponent told him about the number 1. In other words, it is a well-defined number. It's a well-defined concept, and that there are many operations that can give you 1 is totally irrelevant. But, mainstream academics love straw man arguments. They love to set up false arguments. So he proceeds then to show in his first part that 0.999 with the ellipsis following it is actually shorthand for a series. Okay, so it's shorthand for a series, which, by the way, is the reason you can't say find me a number between 0.999 dot 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 and 1, because 0.999 dot 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 is not a number, you moron. And you can only say that if you have two numbers. So in saying that, you're already assuming that this is a well-formed number and that it already equals to 1. Okay, so you're making many assumptions, lots of circular reasoning. You're basically being a typical mainstream idiot. So he carries on and he then says, this is what happens in the series. And let's see what he does now is he gets to a part here where he explains the formula for a geometric series. Okay. And he doesn't understand that this particular expression here is the limit of the series. So let me explain that to you. So, where does this come from? This comes from Euler's Elements of Algebraic, okay, where he says in article 298, he says, I think it is, he says, daher ist uns Bruch 1 over 1 plus a gleich dieser unendlichen Reiche. 1 minus a plus a minus a dot dot dot, and so on. Now this is German, and it says, therefore is our fraction, this fraction here, equal this unending series over here. Okay. Now notice that if S is the series, okay, which it is the series, then this is the limit. This is lim S. And he says that this lim S is equal to S, or that S is equal to lim S. Okay, that's where you get the bullshit support for your 0.999 equals to 1. Is it a good idea to do that? Obviously not, because a sequence is not a number. Okay, this is a well-formed number. This here is not a number. It's symbolic or shorthand for a sequence. All right? So let's just reset the canvas here so we can be ready when we come back. And he continues on here to show that this is a geometric series with that limit. And it, incidentally, this formula that he comes up with only works for r between 1 and minus 1. Okay, because it has to be a common ratio which is in that region. However, the general formula will work for any particular number of terms. Okay, so at the end of the day, he gives you a geometric proof. It's not a proof really. It's a result of this series here, where you see S sub n is equal to a1 1 minus rn over 1 minus r. So as n becomes infinitely large, this part of the fraction becomes very small, and you're left with a1 over 1 minus r. But that doesn't mean you've performed an infinite sum. That's just utter rubbish. Okay, there's no such thing as an infinite sum. You don't have that. Okay, so that's in this particular series. I mean, this particular video of his. He has another crap video which he, I believe, does a similar thing. So let's see. I think it might be this one. So let's see what he says in this one. Okay, so he comes along here. Oh, now we got to wait for the ads, unfortunately. I hate that. Okay, let's get rid of the ads. That's how he makes his money, by the way. Oh, now this here, by the way, is a false proof, and I'll explain to you why it's false. All right, let's see why it's complete. It's not even a proof. It's based on many incorrect assumptions. So you've obviously heard your retarded math teacher or lecturer tell you that if that is equal to 0.999, then 10 times that is equal to 9.999 dot dot dot. Okay, there's already a problem here. You know what the problem here is? That multiplication does not distribute over infinite series, okay? I mean, that's just BS. It doesn't distribute. You can't take this. This here isn't a number so that when you multiply it by 10, you're going to get another number. Do you understand that? It just doesn't work that way. And then the next bit of drivel is that they do a subtraction like this, and of course, subtracting this. And then they say x is equal to 1. And then somehow they say, those two must be equal because we started off with this one and we got that one. Well, there are so many wrong things with that, but I'll give you one very common thing in algebra. In algebra, if you have an object here and you say 10x and 10 multiplied by the object, okay, then you have 9x is equal to 9 times object, like that, and x is equal to object. What that means is what you put in, moron, is what you get out, if algebra is working correctly. But if you have monkey business like you have here, obviously you're going to get something strange. All right? So that's the first part of that idiotic circle proof. Now, I'm going to put a link to an article where I've actually argued all these things with infinitely many morons on the web. This was quite a long time ago, I think in 2013, but I debunk all the proofs. So the three most common ones are the 10x proof, which is the one I've just showed you. The second one says, but 1/3 is equal to 0.333. And again, that's not true because 0.333 as a non-terminating representation is ill-formed. Okay, it has no place in mathematics. And I'll place a link to a video where you can see that you can't take this expression here and multiply it by 3 and then say that 1 is equal to 0.999, because then again, you're doing the same thing here that I told you. Multiplication does not distribute over infinite series. Do you understand that? And I'll put a link to another video which you can watch. It actually proves my point on that one. So And then, of course, the final very common one is that you can't find a number, which is the one I mentioned right at the beginning, between this and this, because they must be the same. Then they must be the same. That's utter rubbish too, because m and n, there'll be a number between them, and only if both of them are numbers. But this here is not a number; it's nonsense. It's shorthand for a sequence. Okay, it's not a number. So, and here I show you, even in this video, proof by partial series, that you cannot say 0.333 dot 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 is equal to a third. Okay, because there's no such thing as a non-terminating representation. It's dysfunctional thinking, syphilitic brains that you find in mainstream professors and teachers. And I show you here using Euler's very same arguments, remains a mystery to me how Euler could have known these things and still have come up with the bullshit S equals to Lem's, where he says, daher ist uns Bruch, 1 over 1 plus a gleich dieser unendliche Reiche. Okay, that's just total bullshit. Okay, so now you can see that there are many forms when you do this, okay? And as long as you have the correct remainder, you don't have a restriction on R, like this guy showed you earlier on, where he said the absolute value of R lies between -1. You don't have a restriction. You can put anything you like in A, B, and C, and all of these will be true. However, if you decide to drop the last term, okay, so if you decide, let's just get rid of it, then you'll end up having a conclusion that is completely wrong. Okay, so I give you lots of proofs in this article. I mean, in this, yeah, it is an article. It's something that I extracted from a site that is no longer online, and there's a good reason it's not online. My mainstream enemies took it down, so it's no longer there. But so I show you, I give you many proofs, and I show you how also the limit argument fails. It's total bunch of garbage. Every single so-called proof is a non-argument. Okay, every one of them. There's not a single one which is correct. So here he goes along and he talks about these things. And he says, let's do that. And then he multiplies by 10. You see the same mistake that I just showed you. Okay. And then he says, therefore, x is equal to 1. Right. But, and he points there with the arrows. But of course, he's made several mistakes here. He's made a mistake in assuming multiplication is distributed over infinite series. In other words, you're multiplying a non-number object by a number, which is 10. You're doing a subtraction here, which is invalid. And then everything after the second step is all invalid and all incorrect. Okay, so it's not a proof of any kind, right? So he of course, he concludes this, which is he's an idiot, obviously. What can you say? I mean, a little Chinese boy or whatever who's being trained by mainstream idiots. So then he gives another example again, showing again how you do the same trick and you end up with, again, a fraction. So this trick is nice when you're trying to convert what mainstream academics think of a non-repeating or non-terminating decimal into a fraction. But these non-repeating or non-terminating decimals are not actually representative of the numbers. So I've written another article called "The Most Important Number Theorem That Mainstream Mathematics Academics Have Never Realized." And basically what it says is that unless you have, say for example, you have P over Q and you want to represent it in base B, unless the prime factors of Q, and I prove this in my article, unless the prime factors of Q are also prime factors of B, you cannot represent this fraction in base B. Okay, so I mean, you might end up repeating things like 0.333 or let's do some other examples here very quickly. I just want to show you something else while we're on it. Okay, so uh, another thing I wanted to show you is, because in another article, the same guy talks about uh, measuring a fifth. Actually, he talks about dividing 1 by 5. First of all, no division is taking place here. It's already taken place. It's gone. It's in the past. Nothing's pending. This here is a very well-defined number, okay? So then he says, okay, take 1 and 5 like that. 5 goes into 1, 0, and then put a point there and 10. So he says that when you divide this, you get 0.2. Actually, that's not correct. Okay, that's totally incorrect. When you do this here, what you're doing is you're measuring a fifth using tenths. Okay, that's what you're doing. So, and I could show you how to do that the proper way. The proper way is like this: you multiply it by 10 over 10, which means that you have 10 over 5 times 1 over 10, which is equal to 2 times 1 over 10. Now, this worked out finally and correctly because 5 is a prime factor of 10. And what's the other prime factor? 2. So the only numbers, the only fractions of the form P over Q that you can represent in base 10 are ones where the factors of this include 2 and 5. Otherwise, and in fact, if it includes any other prime factors that base 10 doesn't have, you won't be able to represent it. Not even repeating, not even non-repeating. So, I mean, they're called that, but they're not exact measures. So, I mean, if you write down something like, for example, a quarter in base 7 is 0.1515, supposedly using mainstream ideas repeated, right? But this isn't a representation of a quarter in base 7. It isn't. It's an approximation, okay? It's a property of the fact that 7 does not contain the prime factor 2, okay? That's why this happens. Otherwise, it would always measure exactly, okay? So what you do when you follow this process here is that you reinterpreting this number. It's a number. It's a name given to a number, okay? It's a name given to the measure of this ratio. 5 of them, okay? 5 of these are measured. That's 1 over 5. And there's nothing to do after this. It's finished. But if you want to convert it to base 10, then what you're saying is put an equal sign there and 10 and find what you need to multiply this here by so that you get 10, right? And the answer is 2 because that's equal to 1/5. And that's the process that you follow here. Now, if you wanted to, for example, do the same thing in another base, the way you would do it is you would say, let's say a third in base 6, right? You'd multiply it by 6 over 6 because I know it's measurable in 6 over 6 because 3 is a prime factor of 6 over 6. And again, 6 over 3 times 1 over 6, that's equal to 0.2 times 1 over 6. Therefore, 1/3 is equal to 0.2 in base 6, okay? So academics don't even understand the fundamentals of radix systems. Your math professor inevitably has no idea that there is no such thing as an infinite decimal expansion. It's a myth, but it suits them fine because their illustrious crank fathers, such as George Cantor and all the others, use things like that in their diagonal misarguments, etc. So again, this guy continues to run through a load of crap and reach all the wrong conclusions. And of course, everybody here goes, wow, what a clever guy, how smart. But in reality, he's an idiot, okay? And he's probably never realized that uh, the reason for these things is a gross misunderstanding of the concept, not only of number, but of the concept of series, which they teach in real analysis courses. So your very own professor doesn't have a clue what is a series or an infinite series. Okay, it doesn't have a clue. And in this article here, to which I'll place a link, you'll see what all of that means. Okay. If you're not already a subscriber, become one, click like, tell your friends about it, follow me on academia. I have many articles, fine articles, the best quality articles on the web. Also, I produce the videos, maybe not the best entertainment videos, but the content of my videos is better than the content in any other mathematical channel. The irony is that I only have, I think, 2,100 and something subscribers, and I earn almost nothing. But morons like this guy and Professor Dave explains, oh, and this pompous English ass with his channel of Numberphile, he has, 4.4 million views, and I think many, many more subscribers. So all these idiots pollute the web with their garbage, and it's basically information brainwashing, and you really can't fight against them. So ultimately, only those who are capable of thinking independently will see that these guys are a bunch of idiots. Very well, then. My name is John Gabriel. Till next time, goodbye.